Hi, everybody, and welcome to our first video here on our group project, where we're going to be looking at capital budgeting and how we analyze a couple of projects. So I'm going to go through three files here as part of showing you how to do the group project. First, there's Steve's Way template, how to calculate weighted average cost of capital, and that uses this file, uh, butterfly illustration. And then I'm going to demonstrate how to calculate net present value and internal rate of return, demonstrate profitability index example, and demonstrate the accounting rate of return, all of which you'll need for the group project. Lastly, we'll take a look at the APA template. This is what we will use to format your paper. Okay, let's get started. Okay, here we are in Steve's Way template, and what we need to do here is take a look at the discount rate, 10%, and here's our periods, period 0, 1, 2, 3, 4, 5, and our factor. Let's take a look at the factor. In period 0, the factor is always 1. As we go down here, you'll see that that has changed to 1.1. How we calculate that is we take the previous cell and multiply it by 1 plus the discount rate. You can see here I've put dollar signs before the A and before the 5. That changes this to an absolute reference, so it is always looking to use 10% as I copy this down. And if I copy this down, we'll do it real quickly here, we'll see that it works perfectly. But as I look at the last one, you'll see that it's referencing C11 here. And while the absolute reference is referencing the 10% still. Okay. Excel defaults to relative referencing. So you have to change it to absolute reference if that's what you want. And that is what we want. Okay. So the 500,000 is cash out. That represents perhaps purchasing a machine. And that's the cash that we spend on that machine, including everything for that machine. It's expected to deliver 150,000 worth of savings every year. So how we would look at that is we would use these factors and divide them into these undiscounted cash flows to get the discounted cash flows here. Those represent the present value of each of these cash ins. And then we add this all up to get $68,618.02. And what that means is that it is greater than 0. That's the decision criteria for net present value. We want to accept a project when the net present value is positive. Now, we don't use this in the group project, but I wanted to show you how to do the Excel function. And this is how we would do it. Here we would just indicate the discount rate. Here is the range of the cash ins. And then we would add the cash out at the end of that function. A little complicated. I can't tell you how many people in the real world have misused that. But nevertheless, you see that it comes out exactly the same as doing it Steve's way. But I think Steve's way provides a better understanding of what net present value is. It's the sum of all these present values here. Okay. Here, I do a different net present value calculation. You can check that out on your own. But over here, which we'll describe here in a few minutes, is the profitability index. And how we calculate that is we take the $16,000 cash out, that's shown here with a minus so that it turns the 16,000 into a positive, and we divide it by the sum of all the cash ins. That profitability index, the decision criteria for that is we would accept a project when the profitability index is greater than 1, which it is in this case. So we would accept this project. Here we have a net present value that comes out negative, and we would not accept this project. Okay, let's look at internal rate of return. And here's our original example here. And if we want to calculate the internal rate of return, I'll do this somewhat slowly so that you see how we do that. We go up here. This is on a PC now, so you'll have to make a few little adjustments if you're using a Mac, but the process is identical. You find the data tab here, and then we go over to the what if analysis, which is here. We hit the down arrow and select goal seek. Up comes this little dialog box here. And what internal rate of return is that the discount rate that drives net present value to 0. So we want to set this cell, so we could use this as our and select net present value, then hit enter. And we want to make that equal to 0. And what we want to change is this 10%. I hit enter again, and now it's all set up. All I have to do is hit OK, and you see that it changes it to 1524. We think that's okay, so I hit OK again. See how that works? Okay, I'll do that one more time just to show you slowly how I did it now that you've seen it once. You'll need to do this for your group project. So what we do here is we go to the data tab here, go over to what if analysis, select goal seek, up comes this dialog box. We want to set this cell equal to 0 by changing the 10%. And once it's set up like that, we just hit OK and OK again. Now you'll see the net present value is equal to 0. The discount rate that drives that to 0 is 15.24. Now, if I did it in Excel, it has a function as well. You won't need that for your group project. But as you see, it picks up all this range and uses a 10% discount rate in this function in Excel. And it comes out exactly the same. Okay, let's look at simple payback. Simple payback, or payback as it's called in the text. Here, we're going to be using undiscounted cash flows. So I've highlighted those in red so that you can see that. And essentially what you do to calculate that is that you bring this 500,000 over. You can see that's all I've done here. And then we're going to take this cell, the 500,000, and add this to it. You can see that reduces that 500,000 by 150,000. And we do that all the way down. All we have to do is copy that formula and poof, it's already done. Now, how you would look at this is you would say, okay, somewhere between the 3rd year and the 4th year, this project breaks even. So I need to calculate what percentage of the 3rd year, or call it the 4th year, that is used here. And we would do that by dividing 50,000 by 150,000. And as you see in the formula that I have here, that's exactly what I do. I bring the 3 periods over, 3, plus the 50,000 divided by the 150,000, which is 0.33 years. Add them together, and you get 3.33 years. And away we go. Now, because this project has an equal cash ins in all the years, it's a pretty easy calculation to do alternatively this way. We just take 500,000 and divide it by 150,000. And that's going to get you the same number, 3.33. But if these cash flows are different, which they almost always will be in the real world, you have to go through this process that I just showed you for calculating simple payback. All right. So break-even time. Let's take a look at break-even time. Break-even time, what we're going to do here is we're going to use discounted cash flows, and we do it exactly the same way. And you can see that the difference here, we break even after the 4th year, so our calculation is going to be 4 years plus this 24,520 divided by 93,138. And that is how we do those calculations. That looks like a good place to stop this video, and when we return, we'll carry on with the next instructions.